Now, we discussed in the first week how the processes involved in household water treatment are the same processes used in conventional water treatment at community or municipal scales. But professional treatment at these scales typically involves multiple barriers to contamination, especially when surface water is being treated. We've seen that some pathogens are more resistant to certain kinds of disinfection than others are, and that for this reason you might have water with no E. coli bacteria, but still contaminated with hardier microbes, such as Cryptosporidium cysts. Well, Cryptosporidium cysts are large, so filtration is normally more effective than disinfection in ensuring that drinking water doesn't contain crypto. It's more difficult, naturally, to apply multiple treatment steps at the household scale. It's hard enough to correctly and consistently apply one treatment step. How much harder is it if 2 or 3 steps must be followed? Perhaps for this reason, there are relatively few examples of informal combinations of multiple barriers in HWTS. There are, however, a good number of commercial products which incorporate 2 or more processes in a way that is more or less invisible to the consumer. Informally, there are many different combinations that could be made involving some kind of pre-treatment or filtration, along with a disinfection step, and safe storage. This image from COST shows how a biosand filter can be combined with safe storage, that's an Oxfam bucket there, and COST recommends that people then use chlorine or another disinfectant step before drinking the water. It's not clear how seriously this recommendation is taken in the field, but this kind of combination, say of filtration followed by chlorination and safe storage, is probably the most manageable kind of informal combination. If we look at commercial combinations, one very potent one is the combination of a coagulant flocculant with chlorine disinfection. The coagulant removes suspended particles, allowing the chlorine to act effectively. We saw a video of the coagulation progress from this product, the Procter & Gamble Purifier of Water, in an earlier episode. This product was formerly marketed as Pure, but there are other similar commercial products such as Water Maker, developed by Control Chemicals in South Africa. This combination is particularly good in emergencies where water might be highly turbid. In fact, the more turbidity in the water, the better the coagulation process works. A drawback is that a large-mouthed container is needed to add the chemicals to the water and stir it well. You can't do that in a jerry can. Then, a second container is also needed, which might be a safe storage container, like this one with a tap, since the treated water should be filtered through a simple cloth before use to remove any remaining flocks. There are many more commercial systems based on the combination of filtration and disinfection, typically with chlorine, particularly targeting middle-income or upper-income households. These systems work best with water that has only low levels of turbidity, since their filter elements could easily get clogged if there were high levels of suspended solids. These filters are particularly popular in Eastern and Southeastern Asia, but are growing in popularity throughout the world. Here you see the Aquasure filter produced by Eureka Forbes and Hindustan Unilever's Purit. Both of these include a chlorine cartridge, which is called something else, something innocuous like the germ kill battery in Purit, which must be regularly replaced. The Purit uses a secondary activated carbon block following the chlorine step to remove residual chlorine, so there's no taste for the consumer. The Tata Swatch filter uses colloidal silver as the disinfectant, and mineral pot filters are produced by a variety of companies and sometimes branded as Korean filters. They typically don't have a chlorine disinfectant, but do have small amounts of various porous materials such as activated carbon, zeolites, or ion exchange resins that may or may not help remove pathogens. All of these filters do have built-in safe storage, and most require regular replacement of filtration or disinfection cartridges. Most of these companies produce a range of products targeting different types of consumers, including high-end models not discussed here that require electricity and do things like fill automatically or produce chilled water. So in summary, the multiple barrier approach, which is critically important in conventional water treatment, it can also be applied at the household scale. Multiple barriers provide greater chances of removing or inactivating all of the different kinds of pathogens which might be present in the raw water. Combinations can be done in informal systems, but are probably more effective in commercially designed systems. And the most commonly used combinations are either coagulation or filtration, followed by chlorine disinfection and safe storage.